This videocast introduces the topic of refraction and is aimed at Year 10 students at Key Stage 3 level. We begin then with bending and refracting. As we've already learned, light travels in straight lines. When light passes from one medium to another, for example from air into glass, it may change direction, but it still travels in straight lines. And this change in direction is called refraction. And this can be demonstrated using a glass block and a ray of light produced from a ray box. The light comes in at an angle, meets the surface of the glass block, it changes direction as it passes through the glass block, and then bends again as it leaves the glass block. Now you're going to try and understand why this happens. A good example to explain this is if we imagine a car driving from a road into a muddy field at an angle. In the muddy field, it's going to slow down as there's more resistance to its movement. And if it enters at an angle, the front tyres hit the mud at different times. In this diagram, the first tyre meets the mud first, so it gets slower. But tyre 2 is still travelling at the same speed as it initially was, so it pushes on. Tyre 1 is caught in the mud, so the car turns. And if we were to draw a normal in this diagram, remembering a normal is always at right angles to the surface, we would see that the car turns towards the normal. Then, as the car passes through the mud, both wheels are travelling at the same speed. When it comes to leaving the mud again, tyre 2 then meets the road first, and the car bends away from the normal again. So it bends, or rather turns, away from the normal. And this can be used, the same thing happens whenever a ray of light is coming, meets the surface of a glass block and travels through the glass block, bending towards the normal, and then bends away from the normal again. Now why does this happen then? Why does light change direction? If we think about if the car approached the muddy field at an angle of incidence of 0 degrees, in other words along the normal, then both front tyres would hit the mud at the same time. Both tyres would then have the same speed to each other, so the car would just pass straight through the mud and would not change direction. All that would happen would be it would just slow down. And the same happens light. It slows down as it moves from one medium into another. Let's have a look then at how we would draw a refraction ray diagram. So what would happen if the light ray hit the glass block at an angle? Well, let's draw a ray of light coming from the ray box. And again, this is the incident ray. And we then need to draw a normal at 90 degrees to the surface of the glass block. And this is our angle of incidence. The ray bends towards the normal. So the angle in here becomes a lot smaller than initially. And again, as it leaves the glass block, it bends away from the normal. So as the ray enters the glass block, it bends towards the normal. And as it leaves the glass block, it bends away from the normal. And if you were to measure the angle of incidence and the angle of exit from the glass block, you would find that these are equal. In other words, these rays are parallel. What would happen if the light ray hit the glass block at 90 degrees? Well, if the ray's coming in at 90 degrees, it's like the car entering the muddy field. If both wheels hit the mud first, together, then they just pass straight through without any deviation or refraction. So if they hit at 90 degrees, the angle of incidence is 0 degrees. So it travels along the normal and passes straight through the block and out the other end. Let's remind ourselves then why light changes direction. It's like the car. When light hits a medium at an angle to the normal, remember we're always referring to the normal, light bends or refracts in a similar way to that described for the car in a muddy field. Part of the light ray meets the surface before the rest and slows down before the rest. And this causes the change of direction. If the light enters a new medium along the normal, so that the angle of incidence is 0 degrees, then it does not bend because all of the light ray slows down at the same time. So the importance is that it's slowing down, and that causes a change of direction when it meets the surface at an angle. Let's think about another example that would help us to understand that. If you were running along a beach and then ran into the water, when would you be moving slower, in the water or on the sand? Well, when we think about it, it's in the water. So we'd slow down when we move from air into water. In a similar way, as light moves from one medium into another of different density, the speed of light changes. Do you think, does light move faster or slower in a more dense medium? Well, it's going to move slower in a more dense medium. Examples of more dense mediums could be glass or perspex or water. And looking at different mediums that we could consider, the speed of light waves depends on the material they're travelling through. They travel through air fastest, and they slow down whenever they meet glass. And if we had diamond, we would find that the speed of light is even slower. If the light waves enter a different material, so they travel from glass into air, the speed changes. And this causes the light to bend or refract. What is important to learn is not only that light bends, but the direction in which it bends. And in order to learn this, we have a handy revision tip. TAG-AGA. It bends towards air when it's going from air to glass, and away from the normal when it goes from glass to air. So let's remind ourselves of that. Bends towards the normal from air to glass, and away from the normal when going from glass into air. So today we have learned that whenever light moves from one medium into another, it will change direction. And this change of direction is refraction. And we also learned that when it moves from a less dense to a more dense medium, for example from air to glass, it bends towards the normal. And when it goes from glass to air, which is more dense going into a less dense, it bends away from the normal.